Hey everyone, and welcome back to the deep dive. You know how this works. You bring us the source material, and we try to distill it down into the most important points.
That's right.
And so today we're going to be tackling a topic that's both incredibly complex and
Profoundly simple.
profoundly simple. Yeah, the origin of life itself.
Specifically, the information in DNA.
Yeah, so to help us navigate this very complex topic, we're going to be looking at Stephen C. Meyer's book, Signature in the Cell.
It really is an incredible deep dive into the evidence for intelligent design.
So how does this book tackle such a big question? Like, where do we even begin with something like that?
Well, Meyer starts with a really interesting analogy.
Okay.
He compares DNA to software,
Okay.
or even language,
Uh-huh.
with its strings of A's, T's, G's, and C's carrying instructions, just like lines of code in a program,
Right.
or words in a sentence.
I see. So it's like a language, but instead of words, it's using these chemical letters to actually like build and run an organism.
That's exactly right.
It's wild.
What's even more incredible is how much information is packed into DNA.
Okay.
And we're not just talking about complexity here, but something called specified information.
Specified information.
Yes.
What does that mean?
Well, think about it this way. Imagine trying to assemble a functional protein by randomly throwing amino acids together.
Okay.
The odds of that happening are astronomically small.
Really?
You would need more attempts than there are atoms in the universe.
So are you saying that the odds of life forming randomly are that small?
Pretty much.
I always thought that given enough time, anything was possible.
It's a common misconception. But even with billions of years
Right.
and all the resources of the universe, the probability of randomly assembling the specific sequences needed for life is just so incredibly small, it's practically impossible.
That's kind of freaky.
And that's the information paradox that Meyer highlights.
So where does that leave us? If random chance is so unlikely, what other explanations are there?
Well, of course, we can't talk about the origin of life without talking about Darwin.
Of course.
Right. His theory of natural selection, it was revolutionary for biology.
Yeah.
It offered a natural explanation for the appearance of design in living things.
Okay, but does it really hold up? I mean, does it fully account for something as complex and specific as the information in DNA?
That's a great question, and that's exactly the challenge that Meyer brings up.
Okay.
Darwin's theory is great for explaining how existing life forms adapt and change.
Right.
But when we zoom out and look at the very beginning of life, the origin of the very first life with its DNA instruction manual,
Yeah.
some really intriguing questions emerge,
Ah.
ones that Darwin himself couldn't fully address.
Huh. So is it kind of like Darwin's theory explains the evolution of a car, but not how the first car was actually designed and built?
I think that's a really good analogy.
Okay.
And it's interesting because even Meyer,
Yeah.
as a young scientist, he was initially skeptical of intelligent design.
Really?
He was drawn into this field by trying to figure out this puzzle of how did this information in DNA arise?
So it seems like a genuine mystery. It wasn't like he was predisposed to this answer. It's something that he was really grappling with.
Exactly.
So what are some of the other scientific theories that are out there that try to explain this? Like, what else are people saying?
Well, there's been a lot of attempts to try to explain this through natural processes.
Uh-huh.
One that's really popular is self-organization,
Self-organization. Okay.
where molecules spontaneously arrange themselves into more complex structures.
Is that like how snowflakes form?
Kind of.
Yeah.
Snowflakes have a really complex structure,
Uh-huh.
but it's based on the very simple physical laws governing water molecules.
Right.
So the big difference, though, is that snowflake patterns are determined by simple physical laws,
Mm-hmm.
while the sequence of bases in DNA is more like a code.
Mm-hmm.
It's like a language.
Right.
It's not just the molecules themselves, but the very specific arrangement that carries meaning.
So it's like the difference between a pile of lumber and then like a beautiful table that's been crafted. Like the wood is just material, but the table has a specific form and function that's based on the design of a carpenter.
That's a great way to put it.
It seems like a pretty big difference.
It is, and that's one of the main problems with the self-organization idea.
Okay.
It can't account for the specific arrangement of information in DNA.
Okay.
Another popular idea is the RNA world hypothesis.
Oh, I've heard of that one.
Have you?
Yeah, isn't RNA kind of like a simpler version of DNA?
Yes, it is.
Okay.
And so the idea is that because RNA is simpler, maybe it came first
Mm-hmm.
and then later evolved into DNA.
Okay, but doesn't that just shift the problem? Like now you have to explain where the RNA came from.
It's exactly right.
Okay.
RNA still carries genetic information,
Right.
and it requires complex proteins to function and to replicate.
Mm.
So it becomes kind of a chicken and egg problem.
So you need proteins to make RNA, but you need RNA to make proteins.
It's a paradox.
Yeah, I see.
And so even the RNA world hypothesis doesn't fully answer the question of where that initial information came from.
Okay, so we've got this information paradox, and even the most popular scientific theories don't seem to fully address it.
Yeah.
So what does Meyer propose instead?
That's where intelligent design comes in.
Okay.
Meyer argues that certain features of the natural world, especially the information encoded in DNA, are best explained by the activity of an intelligent agent.
So you're saying kind of like how we recognize human intelligence in things like computer code or a written message, we can recognize that same kind of intelligence in the information encoded in DNA.
Exactly.
Okay.
He uses a great example from archaeology.
Okay.
Imagine archaeologists uncovering ancient inscriptions.
Yeah.
Even if they don't know who created them,
Right.
they immediately recognize that this is the work of an intelligent mind.
Wow. I never thought about it like that, but I guess it is kind of intuitive. We create information all the time, so why couldn't it be possible for an intelligence to be behind the information in DNA as well?
Right.
But, there is a lot of pushback against intelligent design. I've heard people say that it's not even real science.
That's a common criticism.
Yeah.
But Meyer argues that intelligent design is actually a valid scientific approach.
Okay.
It's based on the method of what we call inference to the best explanation.
Okay.
We use this kind of reasoning all the time in fields like archaeology, forensic science,
Right.
even in everyday life, like figuring out, who stole the cookies from the jar.
Right. So instead of directly observing something, you're looking at the evidence and trying to figure out what the most likely cause was.
Exactly.
Okay.
And when we look at information-rich systems like DNA, our experience tells us that intelligence is the most likely cause for that kind of complexity.
Makes sense, but couldn't someone argue that we're just projecting our human experience onto the natural world? Like maybe there's some natural process out there that we just haven't discovered yet that can generate this kind of information.
That's possible. But appealing to unknown processes is a little bit like saying magic did it.
Right.
It's not really a satisfying explanation from a scientific perspective.
I see what you're saying.
So Meyer argues that intelligent design, even though it might sound unconventional,
Yeah.
is actually a more rigorous explanation because it relies on something we know exists, intelligence as a causal factor.
Okay, so you're saying that intelligent design, even though it might sound kind of out there, is actually more in line with the way we already do science.
Yes.
Because we're looking for a cause that we already know exists.
Exactly. And he's not saying we have all the answers about the nature of that intelligence.
Right.
But he's saying, based on the evidence, it seems to be the most plausible explanation.
Okay, that's interesting.
He compares it to finding a message in a bottle.
Okay.
You wouldn't assume that the waves in the sand just randomly arrange themselves into a coherent message.
Right. You would assume that there was some intelligent being that put that message in the bottle.
Exactly. And the more complex and specific the message,
Right.
the stronger our inference would be
Yeah.
that an intelligent mind was behind it.
Okay.
And in the case of DNA, we're not just talking about any message.
Right.
We're talking about a message that contains the blueprint for building an entire organism.
That's crazy.
And that, to Meyer, strongly suggests an intelligent origin.
Okay, but I thought another criticism of intelligent design was that it wasn't testable.
Right.
Like, you can't really do experiments on it.
Yeah, Meyer actually addresses that in his book.
Okay.
Well, he suggests a couple of ways.
Okay.
One way is to compare the explanatory power of intelligent design against the materialistic theories.
Okay.
Which one provides a better fit for the evidence?
Right.
This is how scientific progress often happens.
Right.
Different theories battle it out, and the one that explains the most data wins.
Okay, so it's like a scientific showdown.
It is.
But I mean, isn't it hard to compare something like intelligent design, which is kind of like a broad concept, to very specific scientific theories?
It is.
Yeah.
And that's where the second testing method comes in.
Okay.
Meyer suggests that we can look for specific hallmarks of design in biological systems.
Like what?
For instance, irreducible complexity.
Oh, yeah, I've heard of that.
Have you?
Yeah. Isn't that like the idea that some biological systems are so intricate that they couldn't have evolved gradually because they need all their parts in order to function?
That's exactly right.
Okay.
Like, think about the bacterial flagellum.
Okay.
It's this tiny little whip-like motor that propels bacteria around.
Yeah.
It's made up of like all these different interlocking parts.
Right.
And if you remove even one, the whole thing stops working.
It's like a mousetrap. Right. All the pieces have to be there
Exactly.
in order for it to work.
Exactly.
Yeah.
And this presents a real challenge for Darwinian evolution, which relies on these gradual changes over time.
Right.
How could such a complex system evolve step by step if it needs all of its parts to function right from the beginning?
That's a really good point.
And so this presence of irreducible complexity
Yeah.
in biological systems could be seen as a fingerprint of intelligent design.
Like a sign that a designer put all those pieces together at once.
Exactly. And there are other potential hallmarks of design that scientists are investigating,
Oh, like what?
like the fine-tuning of the universe for life,
Right.
or the sudden appearance of new biological forms in the fossil record.
So you're saying that intelligent design isn't just this philosophical argument?
Right.
It's actually making testable predictions about what we should find when we look at the world around us.
Exactly.
That's really cool.
It is. And so,
But even if we grant that intelligent design might be a valid scientific theory, doesn't it still leave a lot of unanswered questions?
of course, science is all about asking questions and seeking answers.
Right.
And intelligent design, like any scientific theory,
Yeah.
raises its own set of intriguing questions that scientists are actively exploring.
Like what?
What is the nature of this designing intelligence?
Right.
And how did it act in the world?
Yeah. Those are big questions.
Huge questions. And they're questions that go beyond the scope of science alone.
Right.
They delve into philosophy,
Mm-hmm.
theology, even metaphysics.
So it's not like intelligent design is giving us a complete picture or a final answer?
Not at all.
Okay.
It's opening up a whole new realm of inquiry.
Right.
It's challenging us to think beyond our current understanding and consider new possibilities
Yeah.
that might have seemed off limits before.
This is making me rethink some of my assumptions.
I think that's great.
Yeah. It's like we've gone from looking at DNA as purely material code to actually seeing it as a potential message, a signature of something beyond the physical world.
I think that's a really great way to put it.
That's kind of trippy.
It is, and that's what makes this deep dive so exciting.
Yeah.
We're not just learning facts.
Yeah.
We're grappling with these big questions about the nature of life, the universe, and our place in it.
It's like we've taken this giant leap from the microscope to the cosmos.
I like that.
We're pondering the ultimate mysteries.
Yeah.
This is a lot to digest. Where do we go from here? Okay, so we left off talking about how Meyer isn't totally convinced by some of the other prevailing theories out there, like the RNA world hypothesis. What are some of the issues he brings up about those?
Well, he has a couple of main points, like with the RNA world hypothesis. Even if we assume that RNA did come before DNA, it still requires these really specific arrangements of nucleotides to actually work.
And just to remind me, nucleotides are
The building blocks.
the building blocks of RNA and DNA. Okay.
Exactly. Like, imagine you have all the right Lego bricks to build, say, the Millennium Falcon.
Yeah.
They're not just going to magically assemble themselves
Right.
into the spaceship. You would need instructions, a blueprint.
Right. So having the pieces isn't enough. You need that information to tell them how to go together.
And that's exactly what Meyer's arguing.
Yep.
None of these other theories can explain where that blueprint came from.
Okay, so it's not just about the chemistry, it's about the information, the instructions, and that's what Meyer thinks points to something more than just random chance. I'm really starting to get curious about this intelligent design thing. How does Meyer even start to build a case for that?
Well, he uses this method called inference to the best explanation.
Mm,
It's like being a detective.
okay.
You look at all the evidence, and you consider all the different possible causes, and you try to figure out which explanation makes the most sense.
So we're not talking about some kind of mystical revelation or anything.
No.
We're talking about a logical process
It's a logical process.
of looking at the evidence and drawing conclusions.
Yeah, and in the case of DNA, our experience tells us that intelligence is a really good explanation for this kind of complexity. I mean, think about it. We create information all the time.
Right. We write books. We make computer programs.
We write music. We
Yeah.
do all these things that require intelligence.
Yeah, but couldn't someone say, well, you're just projecting your human experience onto the natural world? Like maybe there's some natural process that can generate this kind of information that we just haven't discovered yet.
Sure, they could say that. But that's kind of like saying magic did it.
Yeah.
It's not very satisfying as a scientific explanation.
So you're saying that even though it might sound kind of strange, this intelligent design idea might actually be a more rigorous explanation
It could be.
because it's relying on something that we already know is real.
We know that intelligence exists.
Right.
We see it all around us.
We know it can create information.
Right.
Okay, so Meyer's not saying that we have it all figured out
Of course not.
about like who this intelligence is or
Right.
how it works, but he's saying based on what we do know, this seems to be a reasonable explanation.
A better explanation
A better
than
explanation.
just random chance.
Okay. He uses an analogy in the book about finding a message in a bottle.
Yes. A very famous analogy.
I mean, we wouldn't look at that and think, oh, the waves in the sand just randomly put that message together. We
Yeah.
would think, oh, somebody wrote this and put it in this bottle.
Someone intelligent.
Right. And the more complex that message is, the more convinced we would be that it came from an intelligent source.
And the message in DNA is incredibly complex.
Right. It's got the instructions to build an entire organism.
Exactly.
That's pretty wild.
It is. And to Meyer, this is really strong evidence that there's some kind of intelligence behind it.
Okay, but how do you test that idea? Like, I thought one of the criticisms was that intelligent design is not testable.
Meyer actually has a couple of ways that he suggests we can test it.
Okay, what are they?
Well, one way is to compare the explanatory power of intelligent design to other materialistic theories.
Okay.
Which one actually explains the data better.
Right, so you're basically pitting the theories against each other and seeing which one comes out on top.
Exactly.
That's kind of cool.
Yeah.
But is it even possible to compare something as broad as intelligent design to very specific scientific theories?
Well, that's a good question, and that's where the second method comes in.
Okay.
He suggests looking for specific signs of design in biological systems.
Okay, are we going back to irreducible complexity?
Yes.
Okay.
We're talking about things like the bacterial flagellum,
Right.
which is like this outboard motor that some bacteria use to swim around.
Right, and it can't evolve gradually because it needs all its parts to work.
You got it.
It's like a mousetrap.
Exactly.
Yeah.
And for Meyer, this irreducible complexity is a strong indicator of intelligent design.
So it's like a fingerprint of the designer.
Yes, and there are other things too,
Like what?
like the fine-tuning of the universe for life
Right.
and the sudden appearance of new life forms in the fossil record.
So intelligent design isn't just this philosophical argument.
No.
It's making predictions about what we should find in the real world.
Exactly.
That's pretty amazing.
It is.
But even if we say, okay, intelligent design might be a valid scientific idea, doesn't it still leave a lot of questions unanswered?
Of course, and that's what makes science so fun.
Yeah.
It's all about asking questions and looking for answers.
Right. And intelligent design, just like any scientific theory, is going to raise more questions.
Absolutely.
What are some of the questions that it raises?
Well, some of the big ones are like, what is the nature of this designer?
Right.
And how did this intelligence actually interact with the world?
Yeah, those are some really big questions. Huge questions. And they're questions that go beyond science.
So we're talking philosophy.
Philosophy, theology, maybe even metaphysics.
So it sounds like intelligent design isn't claiming to have all the answers.
No, it's just offering a different perspective, a different way of looking at the evidence.
It's a new way to think about things.
Exactly.
And a new set of questions to ask.
Yeah.
I like that.
Me too.
It's like we've gone from thinking about DNA as just this material thing to thinking about it as maybe a message,
A message.
a sign of something beyond just the physical world.
Yes,
That's kind of mind-blowing.
it is. And that's why I think this topic is so fascinating.
Me too.
It makes you think about some of the biggest questions out there.
About life, about the universe. Exactly.
And
about
our place in all of it.
It's a big universe out there.
It is, and we're just this tiny little part of it.
A very small part.
But maybe a really important part.
Maybe.
This is a lot to take in.
It is.
Where do we go from here? I am like, wow, my brain is fried right now.
I know, right?
We've covered so much stuff.
It's a big topic.
It is the information paradox, those materialistic theories, trying to explain the origin of life, intelligent design, all this stuff. And we even talked about ways that you could actually test it, like scientifically.
It's pretty amazing.
It is. It feels like we've gone on this journey from like the tiny world of DNA all the way out to the whole universe.
I like that analogy.
Yeah, like we're thinking about some of the biggest questions that humans have ever asked.
It really makes you think.
Yeah, it does. But I gotta say, like, even just considering the possibility that there might be like a mind behind DNA,
Yeah,
it just opens up like all these crazy possibilities.
it really does.
Like, what does that even mean for us? Does it mean that life has a purpose or a meaning beyond just what we can see and touch?
I mean, those are the really big questions.
Yeah.
It definitely challenges like the purely materialistic view.
Right, like that we're all just the product of random chance and there's no bigger meaning to any of this.
Exactly.
Yeah.
Intelligent design suggests that there might be something more,
Right?
something beyond just the physical world that played a role in shaping life and maybe even the whole universe.
Whoa. I mean, it's like we've been living in this black and white world,
Yeah.
and now somebody just like turned on all the colors.
It's a whole new way of seeing things.
Right, and it makes you wonder about this intelligence. Like, what is it?
Yeah.
Can we even understand it? Does it have like a personality?
Those are great questions.
Yeah, and is it still like out there doing stuff?
I don't know.
It's crazy to think about.
It is.
I guess we're kind of moving out of the realm of science here.
A little bit, yeah.
We're getting into like philosophy and even like spirituality.
Yeah, I think that's right.
But it seems like even if intelligent design is true as a scientific theory, it doesn't really tell us who this designer is.
That's right.
Like what their motives are.
Exactly.
It just tells us that there probably is one.
It's like finding a really beautiful piece of pottery.
Yeah.
You can admire the craftsmanship,
Right.
even if you don't know anything about the potter who made it.
Yeah.
Yeah.
So we can see the evidence of design,
Yeah.
but we don't know who the designer is.
We don't.
Yeah. Okay. I get it. I'm starting to see why people find this whole topic so fascinating.
It's really deep stuff.
It is. It's like, it's not just about science. It's about like how we see the world, how we see ourselves.
It makes you question everything.
Yeah, it does. I'm curious, does Meyer talk at all about like what intelligent design could mean for humanity? Like if it's true, what are the implications?
Yeah, he talks about that towards the end of the book.
Okay, what does he say?
Well, he says that intelligent design could completely change how we see ourselves and our place in the universe.
Right? It's not just about like how life began.
It's bigger than that.
It's about like the meaning of life.
Yeah.
It's about whether or not we have a purpose.
Exactly. It challenges the idea that we are just accidents.
Right, like we're just cosmic dust that happened to come together in a certain way.
And it suggests that maybe we're part of a plan,
Wow.
a grand design.
Like maybe we're not just insignificant specks in a meaningless universe.
It's a completely different way of looking at things.
It really is. I don't know if I'm ready for that kind of responsibility.
It's a lot to take in.
It is, but I feel like this whole conversation has really opened my mind up to some new ideas.
That's what we're hoping for.
Yeah, it's like we went from focusing on this one tiny little molecule, DNA, yeah, to thinking about some of the biggest mysteries in the universe.
And some of the oldest questions.
Yeah, and I gotta say, I'm walking away from this with more questions than answers.
That's okay.
Yeah, but it's like, it's a good kind of confusion.
I know what you mean.
Yeah, it's making me want to learn more.
And that's the whole point.
Yeah, to keep exploring, to keep asking questions.
To never stop learning.
So to all of you listening out there, if you're interested in this topic, I highly recommend checking out Signature in the Cell for yourself.
It's a great book.
Yeah, Meyer presents a really compelling argument.
He does. And even if you don't agree with everything he says,
Right.
it'll definitely make you think.
For sure. Well, this has been an amazing deep dive.
I agree.
We've covered so much ground, and I really appreciate you taking the time to walk us through all of this.
My pleasure.
And to everyone listening, thanks for joining us on this intellectual adventure.
It was fun.
We'll see you next time for another deep dive into the world of ideas.
Until then.
Keep those brains buzzing.